Hey there. So by now, everybody should know that an atom has electrons around the outside, but where exactly are they? Um, there was an experiment by Niels Bohr, just kind of summarizing here. He found that light is quantized. So basically, that means that it has particular levels. It's not a spectrum, but there's particular levels. And so he hypothesized that because atoms emit specific wavelengths of light, quantized levels of light, that must mean that the electrons occupy particular energy levels, kind of particular spaces around the atom, excuse me, around the nucleus. And since then, we've learned more information about atoms. We know this is not 100% accurate, but the fact that there are energy levels is actually true. So I want you to learn how to draw Bohr models. So this you do need to memorize right here. The fact that the first energy level can hold 2 electrons. The second one can hold 8. The third one can hold 18. And I'll explain why in just a minute here, but that's the first thing that you need to know. The second thing that you need to know is that you start from the bottom. In other words, you start closer to the nucleus, fill up as much as you can, then you keep adding the next levels, next levels, next levels. So just like I said, first step, find out how many electrons there are. Then start from the middle, in other words, the ring that's closest to the nucleus, and then go from there. So here's an example. I'm going to do this. Why don't I just do this on the whiteboard right now so you can kind of see exactly what I'm talking about. All right, so we're going to start with oxygen. Just getting everything set up here. Hopefully it's recording my whiteboard. We're going to start with oxygen. This, hopefully you can see, is element number 8 on the periodic table. So that tells us that we have 8 protons in there. And if I just have oxygen, we're just going to assume that that's a neutral element, that the same number of protons and electrons are there. So I'm just going to have a space in the middle. This will represent my nucleus. I'm just going to write 8 protons there. If I look at the mass, I don't know if you can see this here, it says 16, or roughly 16, 15.99999. So that means total mass inside the nucleus is 16. So that means I also have 8 neutrons. Now, how many electrons do I have? Remember, electrons are negative. They balance out how many positives and negatives there are. Electrons are negative. So if I have 8 protons, those are positive, I must have 8 electrons that go with it. So in my first ring, just put 2 dots on it. That's the max that it can hold. Then after that it's full, I have to go to my second level. 1, 2, 3, 4, 5, 6. So in total now I have 8. And here I have to stop. Even though the second level can hold 8, I ran out of electrons. Now, this is the Bohr model for oxygen. Now let's say that this is an oxygen ion. So let's say, I'll just do this over here. And you can't see that. I'll do it over here. Oxygen tends to form a -2 ion. So we'll draw kind of a mini version here. First level will have 2. These are called our core electrons. They're on an inside level. Second level, I'm going to have the same ones we had earlier, 2, 4, 6. But since this is a -2 ion, that means I have 2 extra negative charges. So those are 2 more electrons. So 2 more will be here. So now I have a total of 8 on my outer shell. So that's why it's considered a -2 ion. Later on, we're going to learn that atoms like to have this outside shell full, and that's why oxygen tends to attract and gain 2 more electrons. So this is an example of a Bohr model. So add these to your notes. Okay, so next we're going to do nitrogen. So maybe pause the video and see if you can figure it out for yourself first. So nitrogen, you have to first find it on the periodic table. I see that it's number 7. So there's going to be 7 protons. How many neutrons will there be? It says mass of 14. So that means out of 14, 7 of those are protons. So that means 7 must be neutrons. They're not always going to be equal, but in this particular case they are. And same with oxygen. So notice how as you go, the numbers increase. 7 protons, 8 protons, 9 protons, and so on as we go. Okay, so this is also important for you to know that between the ion nitrogen and the regular neutral nitrogen and the ion for nitrogen, the nucleus does not change. Okay, that's just important for you guys to know. So that if there's 7 protons and it's neutral, that must mean there's 7 electrons. And sometimes we write just E negative since it's a negative charge. So I need to find a home for each of those. Remember, how many does the first level hold? 2. Second level. So now I have 5 left because I had to do 7. So I'll just do 2, 4, 5. So that one's finished. So based on what we just said about the valence electrons, they tend to want to get this outside shell full. What do you think will happen with this? What charge do you think the nitrogen ion will have? So think about it. The core electrons, we're not going to touch them. So these 2 are still going to be here. The valence electrons, either we want to completely get rid of this outside shell. So that would be, like if this is empty, just like this would be a nitrogen 5+, because there's 5 extra positive charges compared to the 2 negative charges we have here. Or, and this is what actually happens, it becomes a 3 negative because I already had 5. So to get to my full 8, I have to gain 2, 3. Nice. I guess you can't see this little edge here. But that's really all there is to it for the Bohr model. You can use the Bohr model to kind of predict what ions will form. You can also, yeah, that's really the main point. So this is the Bohr model. But this is a lot, like it takes up a lot of space. So we also have something called an electron dot diagram. It's very simple. You just take the symbol of the element. So the symbol is just the letter. So here's nitrogen. Just write N here in the middle. And you take just the valence electrons, those ones on the outside, and you just write them here. So there's my neutral nitrogen electron dot diagram. Then for the ion, you just take your symbol and you write, now I'm having a brain fart of if we're supposed to write the charge inside. I think we are. So this would be our dot diagram for nitrogen. So if we go back, do you remember what we did for oxygen? For oxygen, we had how many valence electrons? Do you remember? Remember we had 6 valence electrons on that first example we did? So oxygen, its dot diagram looks like this. And then its ion looks like this. Again, the dots, each one is a valence electron. The core electrons, we're just going to leave them alone. Okay, so last one, we're going to do phosphorus. So phosphorus and its ion. Maybe pause the video and try to do it yourself. Okay, so if I look, 15 protons. How many neutrons? It says 30.9, so that's an average of 31 for the mass. So we're going to say 16 neutrons. So how many electrons does that mean we need to take care of? There's 15 electrons on the neutral phosphorus element. Okay, so first level can hold 2. Second level can hold 8. So 2, 4, 6, 8. Okay, so now total I've used up 10. Next level can hold up to 18, but I only have 5 left, right? 2, 4, 5. Okay, so there's phosphorus. So how many valence electrons does it have? It has 5 because I had 2 on the first level, then 8, so that's 10, then 5 more. So this would be my dot diagram. Did you notice that it looks the same as nitrogen? We'll get to that in just a second. So same thing, phosphorus ion. The nucleus does not change. Two will be here. Next level, 8. So that's 10. So normally this level has 5. Let's think about it. Do we want to take them away? I probably need to show you an example when we take it away. Or is it easier to fill it the rest of the way up? So if it's more than halfway full, and I guess, to say full is maybe the wrong word, because the third level can hold up to 18. In chemistry, you learn a little bit more in depth of the theory here, but the basics is that each energy level is divided into sublevels. So I'm just not going to get into that right now because I don't want to confuse you. We'll just keep it basic. But the third level, it can hold up to 18, but we still it has a threshold of being happy with 8. If you want more info, just Google S, P, and D subshells of energy levels. Okay, so we've got 5. We're more than halfway to 8, so we're going to add 1, 2, 3 to get 8. So this will be phosphorus 3 negative with 8 electrons around it. Oh, you can't see that. There we go. So that's the phosphorus ion. So now that we've done this, what do you notice about the location of nitrogen and phosphorus? Do you notice that they are in the same column? So this is the same group. We're going to learn about groups of the periodic table. The groups have a lot in common with each other. So this whole the way down will have the same dot structure. Different number of core electrons, but the valence electrons are the same. And the valence electrons are the ones that participate in chemical reactions. So that's why they're the same. Or they're similar. They're considered to be in the same family. So let me just show you one more where I'll just go kind of quickly. Let's see sodium here. You can see it's number 11. We have 23 as the mass. So it's number 11, 11 protons. We'll have 12 neutrons. So there's going to be 11 electrons here to go with it. First level holds 2. Second level holds 8, 4, 6, 8. So now I have used up 10. I need the third level just for this one measly electron. So our neutral sodium, its dot structure just looks just like this. So let's say sodium ion. Remember the first, multitasking. Remember, the nucleus and the core electrons are going to be the same as the neutral ion. So I can still draw in these first 10 electrons. And it is customary to pair them up like this. We'll talk more about that later. Now, what do you think? Should I gain 7 electrons to fill it up? Or it'd probably be easier to just lose the 1. I'm less than halfway to 8, so I'm just going to lose that 1. So this is actually done. So the sodium, it has a positive 1 charge because I lost 1 electron. Electrons are negative. So that means I have an extra positive. Because remember, this means I have 10 electrons only to go with my 10 protons. You can't see that. I have to keep moving myself around. So this is our Lewis dot structure. You just show that that outer shell that was there is now empty. Sometimes people will go ahead and just put 8 from this other level. I don't tend to do that, but you may possibly see that. So that's really all you need to know. And hopefully here you can guess that lithium is going to have the same dot structure. See how it has 3? So this first level, so lithium, the first level would have the 2, and the second level would have 1. So since they're in the same group, they're going to have the same dot structure. That's what you need to know from this, because basically everything about the bonding, we're going to learn about bonding, then we'll learn reactions. Everything comes down to the electrons. Electrons are the power player here. So I hope you enjoyed this video rather than some rando on YouTube. Try to keep it fresh for you guys. Have a great day. Thank you so much for watching.